we're going to do the back side. So you should have, ooh, it's frozen. You should have did the back side yesterday for homework minus the top two problems. So take out yesterday's paper, because I'm going to check it anyways. We're going to do the two on the back that we skipped, that I told you to skip but not cross out. And then we're going to do density. Density will be due before you leave. You're going to turn in the density paper before you go. Density is super easy. You'll still have time to even like work on that EOC paper from yesterday. So yesterday's paper, we're going to do 6 and 7 that we skipped. So for number 6, it says at Candy Kitchen, an ice cream cone holder is used to show the size of waffle cones given to customers. Determine the volume of the cone holder shown below. The width of the cone is 3 inches. The height is 5 inches. So you're at Candy Kitchen and they have the cute little waffle cones displayed and you're like, ooh, I really want a waffle cone. Like charge me extra $3. I'll take it. Okay. So we have two shapes. We need to find the volume of the cone holder. So would it make sense to add the shapes together or subtract them? Subtract them because there's a gap. It's hollow where the cone is actually being placed. So we're basically going to find the two volumes and then we're going to subtract the difference. So what two shapes do I have in this picture? I have a square, which is a prism. And then I have a cone. So if you look at your formula sheets for the EOC, let's start with a prism. This is what you get. I think this is very overwhelming, but I would rather you be overwhelmed now and not during the EOC. So let's find a prism. What's the volume formula? Base times height. Big B, H. Big B is the area of the base. So what shape is my base? A square. How do you find area of a square? Length times width. You could do base times height, but the only reason why I don't put base times height is because then it's going to say base times height times height. Okay. No. It's actually a parallelogram because a square is a parallelogram, which is base times height, which is length times width. So because it's a cube, it's 7 times 7 times 7. So 7 cubed. Which is how much? 343. Okay, we're going to find the cone. So looking at your blue formula sheet, we need the volume of a cone. One-third big BH. Oh, that's weird. The formulas are very similar. They are. Okay, the cone is not length times width. The cone's base is not a square. Sure. It's a circle. So how do you find area of a circle? And it's all on the formula sheet. You don't need to remember it. I'm replacing big B with pi r squared. I'm still timesing by height in the back. So the numbers are given in the sentence. It says the width of the cone is 3. The height of the cone is 5. So how much is my radius? No. 1.5. So we're going to do 1/3 pi 1.5 squared. How much is my height? 5. So take a second. You have to do the exponents first. 1.5 to the power of 2. Then you can times by 5, times by pi, times by 1/3. It doesn't matter the multiplication as long as you do the exponent first. Because PEMDAS for life. Always and forever. What? Did you multiply by pi? I'm going to use 7/8 just because I don't want to round to the very, very end. And then I'm going to minus them. So 343 minus 11.78. Because it's hollow, that's why I'm subtracting them, because there's an empty piece because my ice cream cone is sitting in it. 331.22 or 0.2, however you want to round it is fine. Okay, so number 7 is the same thing. We're going to find the volume of both shapes, and then we're going to subtract it. This one says a hollow sphere fits snug into a foam cube when shipped, so that way the sphere touches the sides of the box when packed. Determine the volume of the packing foam. So you're shipping a glass sphere because, I don't know, whatever. You have two shapes. We have a prism still, and you have a sphere. So take a second, use your formula sheet, look at the blue sheet. It's overwhelming. I'd rather you be overwhelmed now. Find your formula. Yeah, try this one on yourself. You're gonna do the same thing, and then you're gonna subtract the two numbers. Yeah. If I put a circle in a box, yeah, because it says it's touching all the sides, so it's half the width of the box. Try your math problem so you can be smart. Maybe not smart, but smarter. In the end, like change to one thing. I don't care. Yeah.
Maybe multiply 18 times 18 or 18 times 10.
18 times 18.
Oh, yeah.
Where were you?
I was wondering.
Okay. So we're these problems are from yesterday's paper. We're doing those two that we skipped, and then we'll start the new one.
Wait.
Yeah. A genius. It's not, but you'd be surprised.
I'm a bit surprised.
Yeah. Okay, so for your prism, how much should you get? What's the volume of the prism? 9?
So that's what he told me, guys.
Huh? Yeah, 5382. Okay. 5832. Yeah. Okay, so you do 18 cubed, 18 times 18 times 18. Okay, so for your sphere, you're using 4/3 pi r cubed, which is the formula on the blue sheets. That's nice because you don't have to plug anything in for big B. Okay, so your volume for your sphere should end up being 3053.63. You minus them, the final answer is 2778.37. Yeah, because you rounded, you kept more of your decimal here. And then so when you subtracted, the next number would have rounded the 7 to make an 8, which is fine. So yours is more exact than mine because I used only 2 decimals. Okay, so put this aside, keep it out because I'm going to walk around. I'm going to check if you did those bottom ones. You should have did 8 through 14 yesterday. On today's paper is density. So we're still doing volume. Density and volume kind of get smushed together in their own little topic. Okay. For like science class. So welcome to science. Yeah. Welcome back to science. You should have, I don't know when you learned density in science, but you probably have already done density because it's super easy. So density is The way you can remember it is density is mass divided by volume. So it's like the DMV. It's like where you go to get your license. DMV. Have we seen this formula before? Yeah, the DMV. Oh, you've seen the
Oh,
formula?
I see it.
Or you've been to the DMV?
In it and.
Okay, good. So like, yeah, you should at some point in your life.
Pulls massive adult.
Yeah.
Wow.
Yeah. Okay. So what we're gonna do is density is technically the amount of mass. Mass is the weight of an object, okay? So mass specifically is the weight. Density is the amount of mass or the amount of weight that an object has in a single unit of volume. So you have to think about this. You find volume and it's usually like a big number, okay? Because that's how much fits into a space. The density is taking your weight of that object and dividing by how much volume is there. So it's basically finding out a single unit of single unit of volume. So it's basically the like per cubic inch or per cubic centimeter, or whatever the units are. So you're usually going to get really small numbers for these. Okay. So what we're going to do is we're going to divide the mass by the volume. So let's start with our example. It says a standard brick, which I'm sorry, your picture is ugly, but it is what it is. A brick has dimensions shown below. If the mass, so the weight is 2 kilograms. So I'm going to say M equals 2. My weight is 2. My mass is 2. I need to find the density. To find the density, I need to take my mass. I have to divide by my volume. I don't have my volume because I have to find volume. It's a prism. So what's my formula for a rectangular prism? Big B times H. Big B is going to be length times width because it's a rectangle. So we're just doing length times width times height. So take a second in your calculator, multiply those 3 numbers together so we can get our volume. $66.15. Okay, so then we're going to use our density formula. Density is equal to mass divided by volume, DMV. I'm going to take my mass, which is 2. I'm dividing by the volume, which is 66.15. And you get something really small because this represents the weight per cubic inch of the brick. 0.03. So 0.03. And that's it. That's easy. Okay. So it's going to usually be a really small number because you're taking this big of volume and then you're basically figuring out how much each little square inch in that object weighs instead of versus the whole weight. Okay. So number 1 down here, it says a section of a trunk of a pine tree. So a pine tree is a really long cylinder because it's a tree. Is a cylinder with dimensions shown below. If the mass of the trunk of the weight is 531 kilograms, so my mass is 531. I need to find the density again. First thing I'm going to need to do is find the volume of the cylinder. So if you look at your blue sheet, what's your formula for volume of a cylinder? B times H, big B times H. And this formula keeps coming up because the formula is like basically the same. Big B changes. Yeah. The big B changes to what? No, because it's not a square. Pi r squared because it's a circle. So pi r squared times height. So what's my radius? 0.5. So take a second. I want you to find the volume and then attempt to find the density. Easy, easy, lemon squeezy. Now if your volume's wrong, then the density is obviously going to be wrong. So be careful with your volume. Yeah. The more decimals you use for the volume, the more likely like your answer in the end is going to be closer to what they're wanting.
How does the Why'd you get 0.5?
Because if the diameter is 1, remember the radius goes from the center out, so you need half of 1. Oh, right.
Dude.
We're doing some of the back. Okay.
I got 44 of them.
Did anybody find the volume yet? Like 1 point something? I'm gonna use 3 just because like. Only because like if you're rounding the volume and then you round again at the end, it's just gonna keep getting thrown off by a little bit. So whenever you are doing your EOC and 3D shapes, you want to keep as much as your decimal as possible until the very end. So now I'm going to take my volume. I'm going to plug it into my DMV, just like where you drive at, DMV. I'm going to plug it in. My mass is 531. I'm dividing by my volume, which is 1.178. And I'm going to divide. Okay, so what do we get? Like 450? 76? Yeah, right? Okay. How do we feel? This isn't bad, right? Not terrible. Okay. Let's go to the next one. Number 2. What shape is this?
It's a pyramid.
It's a pyramid, like in Egypt. Okay. So the pyramid. Okay. So look at your formula sheet. Pyramid. Yeah. But like, what's your formula for a pyramid? 1/3 big B H. Your base is not a circle. So I'm not using pi r squared. What am I going to use?
Length times height times width.
Length times width times height. Okay. So the problem is, like Hayden said, your height is not 2.5. You need to find the actual height using Pythagoras. Okay. We're not going to be doing the problems to the right. So what I want you to do is we're going to draw a little triangle. We could do it over here because we got space. Okay. You have 2.5 is the C. That's your hypotenuse. What's going to be the base of the triangle? It is not 3. 1.5. Hopefully at this point in your lives, you understand you can plug the Pythagorean theorem completely into the calculator without even writing anything down. Here you're doing 2.5 squared, because that's C. You are minusing 1.5 squared, pressing equals, and then your shift square rooting. Don't forget to square root. Yeah, bring me your phone, because I sent out a nasty email yesterday. So we're not doing our jobs. Which I feel like I'm pretty good about giving people's phones, but I'm good at that. Yeah. Y'all don't need me mean. Okay, so what's the height? 2. So my height is 2. So we're gonna plug in our numbers. So 1/3, 3 times 3 times dos. Yes, volume is 6.
Yeah.
So find the density,
Oh,
because if you got 18, you have to multiply by 1/3. Perfect. Okay, we're doing one more and that's it. Yes. Okay, so 3 is a little bit different. It says the plastic used to make a solid cone below has a density. So this time I'm given the density. The density is 0.95. So I'm going to put that off to the side. grams per cubic centimeter. Find the mass. So I'm looking for mass. That's what I don't know. Okay. To the nearest tenth of a gram. So I need density, mass, and volume. Basically, I can only have one unknown. So I can find volume off to the side for a cone. And then I'm going to have to use the same formula, but a little bit different. So if I look at my formula sheet, what is the formula for a cone for volume? What's my volume formula for a cone? Basically, if it comes to a point like this or like this, those are the 1/3 problems. If it's just a cylinder that goes straight up or a prism that goes straight up, then it's not using the 1/3. Okay, so my big B needs to change. What shape is my base? Gonzaga. So we're going to do pi r squared here times height. So this one gives us the radius. This one gives us the height. So that's nice. So we're not going to have to change anything. We're just kind of plugging stuff in, which is beautiful. A little ugly because it's got decimals, but it's okay. So PEMDAS for life, 2.2 squared first. Remember, you want to use a couple decimals just so that way in the final answer, you're rounding at the very end. So if that's my volume roughly, I'm going to use the same formula, which is density equals mass divided by volume, which is dmv. So D equals m over v. I'm plugging in what I know. So I know the density this time. The density is actually equal to 0.95. I don't know the mass. That's what I'm trying to find. And I know the volume because I just found the volume. The volume is 38.013. So what could I do? Multiply. So I could multiply both sides by 38.013, whatever. Somebody in first period was like, we can put it over 1 and cross multiply. You can't do that. Same thing. You're either way, you're multiplying these to get your mass. So we'll say a 36.11. Okay, so the rest on the front you can cross out. There's 4 problems on the back that you're doing. Okay. So those 4 problems are going to be. Actually, I'll just tell you which ones you can cross out. So you can skip. Yeah, because I want you to, I know you got testing coming up. I'm giving you EOC reviews. People are giving up on the EOC reviews. I don't know why. But this paper you're turning in before you leave. And then you can work on your EOC review that I gave you yesterday. That way, if you have questions on the EOC review, you can ask it back. Huh? Yes. So no, Thursday. Then you turn it in tomorrow. Here tomorrow. So Friday. And then I'm thinking, here's tomorrow's paper. That we have it, and then that way